Hey mathematicians, it's Justin again, and welcome back to Miaville Adventure Park. Today, Miaville is opening its brand new track-shifting roller coaster, Fate's Freefall. They're holding a contest that anyone can enter to be first to ride the coaster. There are a bunch of games around the park where I can earn entries into the contest. So far, I've earned 8 entries. 1 from my loot bag, 2 from the fortune wheel, and 5 from the balloon darts booth. I am just about to head over to the next contest game, the duck pond. They have these mini ponds with tons of rubber ducks floating in the water. The game is to catch a duck using a magnetic fishing pole. Then the bottom of each duck is marked to indicate how many entries it's worth. What are we doing here? Let's go. I'm at the back of the line right now, but I can see the signs in the booth from here. There are 250 rubber ducks in the pond. 80 of them have a star mark, another 50 have a square mark, 100 have a triangle mark, and all remaining ducks have a circle mark. At this booth, contestants can earn a bonus entry if they correctly predict a type of duck they will not catch. Ooh. So I'm trying to figure out which type of duck I'm not likely to catch. What do you think that looks like in terms of probability? Since I'm thinking about what's not going to happen, that means we need an outcome with the lowest probability, which is the one closest to 0. Let's start by finding the probability of getting each type of duck. Pausing the video here, work on your own to find the probability of getting each type of duck. There are 250 total rubber ducks, broken into 4 types. 80 ducks have a star mark. That makes the probability of getting a star mark 80 over 250, or 32%. Writing up the meaning of your probability like this helps you stay organized, but it's also long. Mathematicians love to be efficient, so they created a shorthand notation for probability. We use a capital P to represent the phrase the probability of. And then, in parentheses, we put the description of what event we're showing the probability of. In our case, we can shorten this to star. To read this, we say P of what's inside the parentheses. So in this case, P of star is 32%. How could we write the probability of getting a square mark using the shorthand notation? We use capital P to represent the probability of. Inside the parentheses, we want to describe what we're finding the probability of, so I'll write square to represent a square mark. Now our notation is P of square. And what is P of square? Out of the 250 total ducks, 50 have a square mark. So the probability is 50 over 250, or 20%. 2 categories left. Let's look at ducks with triangle marks, or P of triangle. There are 100 ducks with triangle marks, which makes a probability of 100 over 250, or 40%. Last up are our ducks with circle marks, or P of circle. Except the sign doesn't tell us how many there are, just that they're the remaining ones. So we know that there are 250 total ducks. If I take away the 80 with a star mark, the 50 with a square mark, and the 100 with a triangle mark, how many ducks are remaining that have a circle mark? 20.
There are 20 ducks with circle marks, which makes P of circle 20 over 250, or 8%.
It seems like I should feel confident I will not catch a duck with a circle mark, since 8% is the lowest probability. But what exactly is the probability that I will not get a duck with a circle mark? Can we figure that out with the information we already have? Pause the video here and try to determine the probability of not getting a duck with a circle mark. Let's talk through this together.
Remember, the probability scale goes from 0 to 100%. Before we go over the probability of not getting a circle duck, let's talk through something that may feel more familiar. Imagine that there's an 80% chance of rain today. What does that mean the chance is that it will not rain? If out of the entire whole, 80% represents the part where it will rain, then the remaining part, 20%, represents the chance that it will not rain. Notice that together, the chance of rain and the chance of it not raining add up to 100%, because together they represent the whole. Let's apply the same thinking to the duck pond. There's an 8% chance that I get a circle mark. So what's the chance that I do not get a circle mark? To get from 8% to 100%, this remaining part is 100 minus 8, or 92%. So there is a 92% chance that I will not get a circle mark. If we bring in the probabilities of getting the other types of ducks, what do you notice? The probability of not getting a circle mark is just a combination of the probabilities of getting a star mark, a square mark, and a triangle mark. Did you notice that if you add the probabilities of getting a star, square, and triangle, the total is 92%? Why do you think that is? If I don't get a circle duck, that's the same thing as saying that I will get one of these types of ducks instead.
Since the probability of me getting a circle mark is 8%, the probability of me not getting a circle mark is 92%. The remaining part out of the whole 100%. It seems like predicting that I won't get a circle mark is a really good choice, but just to be really sure, can you figure out the probability of me not getting each of the other types of ducks too? Pause the video here and try it on your own now.
P of star mark is 32%. That means the remaining part of the whole, 68%, is what's left as the probability that I do not get a star. P of a square mark is 20%. So the other remaining 80% represents the probability of all of the other outcomes, the ones where I do not get a square mark. And lastly, P of a triangle mark is 40%. So the probability that I do not get a triangle is 60%. Nicely done.
Remember, at the duck pond game, if I correctly predict what type of duck I will not get, then I get a bonus contest entry. We notice that I have the lowest probability of getting a circle mark, but now we can also tell that I have the highest probability of not getting a circle mark. These are two different ways to approach the same question, but both ways have given me my answer. I'm predicting that I will not get a duck with a circle mark. Ooh, it's my turn. Wish me luck. I got a duck with a star mark. The woman at the booth said that it was worth 5 entries. Add that to my extra entry for correctly predicting that I would not get a circle mark, and that makes 6 total entries from that duck pond. That brings my total to 14 contest entries. Awesome! Today, we explored how to find the probability of an event happening and the probability of it not happening. Remember, the probability of an event happening and not happening will always add up to 100%. Great job, math team! I have one more contest game left to complete to win more entries. But for now, finish up your guided notes and then head to the online practice to complete levels 1 through 3. Until next time, keep questioning, keep calculating, and remember, predicting what won't happen can be just as powerful as predicting what will. See you next time!
Hey!